So this is lesson 5 on page 641. This is the application that's going to go through the solving systems of equations. And remember that there's 3 different ways that we could solve systems. We could graph systems, we could use substitution, or we could use elimination. In this lesson, we're not going to graph any of the problems. We're just going to solve, and you're going to decide if each question is set up to do substitution or to do elimination. So let's look at this first question. So it's a numbers application. You need to be able to do a numbers problem. So either there'll be a numbers problem on your test, on your quiz, or on the exam. It'll be on one of the two. So it says the difference between two numbers is 9. So a couple of things that I'll let you know that will give you some hints. When you see the word is, that means equals. Okay, so if you see is, that is equals. So the first system, it says the difference between two numbers is 9. So it's going to be something is equal to 9. I'm going to choose x and y for my two different numbers. If the question was the sum between two numbers is 9, it would be x plus y is 9. Because it's difference, what does difference imply? Subtraction. So the first system would be x minus y is equal to 9. That is the difference between two numbers is 9. Okay? Then what we always do for these number questions is you have to tell me which number do you want to be the larger number. Do you want x or y to be the larger number? I always pick the first variable to be the larger one. So just off to the side, I'm going to say let x be the larger number. Okay, that's our first system. Remember, we always need two systems though. So there's going to be a second equation, and that's going to be from the second sentence. It says the larger number is. So I'm going to put this in a box. That's equals. What did I say the larger number was? Was it the x or the y? X. So the larger number is 3 more. 3 more means plus 3. Okay, then twice the smaller number. The smaller number is y, and twice the smaller number would be 2y. So putting this together, if it says 3 more than twice the smaller number, it's going to be 2y plus 3. So x is equal to 2y plus 3. That's my second system. So the larger number is 3 more than twice the smaller is what this would be. This is set up for substitution. Okay, we could do elimination by subtracting the 2y to this side, but right now it's set up for substitution. I'm just going to do substitution because in my second system, they tell me what x is equal to, right? That's what x is. In my first system, I have an x. So I'm going to take x out of my first system and I'm going to substitute in 2y plus 3. Okay, so 2y plus 3 is going to go into the first system. So x comes out, 2y plus 3 goes in, and then I have minus y equals 9. I substituted it into the first system. With substitution, you'll always be able to join like terms. So 2y minus 1y is 1y plus 3 is equal to 9. Subtract 3 from both sides, and you'll get 1y is equal to 6. And then if that was any number other than 1, you'd be dividing that number out, right? So if I divide out the 1, I've got y is equal to 6. So my smaller number is going to be 6 because we said that the larger number is going to be x. Okay, to figure out what your larger number is, we need to know what x is. Here was the system that I could plug y into, right? So in my second system, it was x is equal to 2y plus 3. So now I'm going to take y out because I solved y to be 6. So x is equal to 2 times 6 plus 3. X is equal to 12 plus 3. X is equal to 15. So those are my two numbers, 15 and 6. You have to verify, right? And remember, it has to verify in both systems. I'm going to show you an example of where it would verify in one system and not the other. But the question, the first system was the difference between two numbers is 9. So type on your calculators 15 minus 6 and make sure that the answer is 9. So, oh, sorry, I got it right up here. So 15 minus 6 is equal to 9. It verifies in that first system. The second system was this x is equal to 2y plus 3. So I'll just write that off to the side for the second system. X is equal to 2y plus 3. I got x to be 15 is equal to 2 times y. Y is 6 plus 3. 2 times 6 is 12. Add 3. 12 plus 3 is 15. So the number verifies on both sides. Left side equals right side. Here's a different, some students might say to me, well, why can't these be the numbers? X is equal to 19 and Y is equal to 10, right? They'll say, why can't these be the numbers? This is true for the first system, right? The difference between these two numbers is 9. It is the difference. But it does not satisfy this second system. If you put in a 19 over here for x, right? So if I put a 19 here, and then I said 2 times y, so 20 plus 3, it'd be 23. That does not verify. So just because something verifies in one system doesn't mean it's the answer. It has to verify in both. So the answer would be 15 and 6. So we're going to do a couple of these number ones. Another scenario that you will see all the time is a rectangle scenario. So what I want you to draw for these, and again, either quiz or exam, you will see this scenario. Draw yourself a rectangle. In grade 10 or 10C, they're always going to be perimeter questions for rectangles. In grade 11, they're going to be area questions. Remember that a rectangle, you've got two lengths that are equal, and you've got two widths that are equal. If I said, what is the perimeter of this rectangle? You imagine a person walking around the length of the rectangle. Does anybody know what the formula for perimeter would be? So for example, if I said what's the area of the rectangle, you'd say length times width. That's area. What would the perimeter be using L and W? Anybody know what that would be? What would you say? Nope, not that. So just think this little guy, he's got to go here, then he's got to go down, across, and up. Tristan, what do you think? That's exactly what it is. So before students get to that, they usually say, okay, it would be L plus W plus L plus W. What that is, there's two L's plus two W's. Okay, so let's see if we could get this two systems. Here's the very first system. The perimeter of this rectangle is, there's our equals to, 40. So what is the very first equation? Something's going to equal 40. What is it, Ainsley, that equals 40? Yep, which is what? Nope, Tristan just said what perimeter would be. Yes, 2L plus 2W is equal to 40. So basically, when he goes around this rectangle, he's gone 40 meters, okay? Your second system, so just take a minute and see what you would write. So here's my is, that's where my equals goes. You know what letter this would be, so I'm going to put a W here. What you have to figure out here, 4 meters less than the length, you have to figure out, is it 4 minus L or L minus 4? Who knows what it would be? So think about that for a second. The width is 4 meters less the length. Is it 4 minus L or L minus 4? Who thinks they know what it would be? Evan, what do you think? It's, no, it's actually not 4 minus well. This would be the length less 4. So 4 meters less than, that's going to be minus 4, right? 4 meters less than, and the length is L. It would be L minus 4. Width is L minus 4. If it was 4 meters more, that would be plus 4. So it would be L plus 4. How is this set up to solve? Substitution or elimination? What do you guys think? The way it's set up. Substitution again. I figured out what L or what W is, right? This is set up perfectly for substitution. So let's do substitution again. We know that this is what the width is. And here is the width. So take out the width from the first system and put in L minus 4. Take a minute, expand this, put your like terms together, see if you could solve for L. Want you have what L is equal to? L is equal to 12 meters. Yep. So the length of this rectangle is 12. What I'm actually going to do for the rectangle questions is I go right up here and into my diagram, I'm going to substitute in 12 for the length. Now you have to calculate the width. So you'd say, okay, well, how do I calculate the width? You could take this length and put it into system 1 or system 2. Which system do you think I'm going to plug it into? System 2, it's already set up for me, right? So system 2 was this guy. Width is equal to L minus 4. Width is equal to, I know that L is 12. What would the width be? 8. 8 meters is the width. And then we would check, right? So put 8 meters in for the width. If we add all 4 of these sides, we need to get 40. So 12 and 12 is 24, right? 8 and 8 is 16. So 24 plus 16 is equal to 40. So it adds to 40. So the first system is verified, right? That it adds to 40. And then you just have to verify the second system. So the second system, so let's verify the second system. It was W is equal to L minus 4. We got W to be 8. And we got length to be 12. 12 minus 4 is 8. So I've got 8 on the left, 8 on the right. The system is verified. The answer is 8 and 12. So again, first type of question, it has to be those number questions. Second type is perimeter of rectangles. And then the third is going to be money. Students have the hardest time setting this up the first time, and then it gets easier once you see how this system is set up. Gary has a total of $260 in $5 and $10 bills. So he opens his wallet. He's got a stack of 5s and 10s in there. You don't know how many 5s and how many 10s, but they add up to 260. Okay? So that is going to have to do something with the first system. The first system is going to have to do with like the number of 5s and the number of 10s is going to be adding up to $260. Then the second system is the number of bills he has in the wallet. There's 33 bills total. So it could be like 30 $10 bills and 3 $5 bills, right? They've got to add to 33. We need to choose two different letters. What letter do we want to represent our $5 bill? What letter do we want to represent our $10 bill? So Ainsley, what do you want? Okay, let's do that. She said, let's have our $5 bills F and our $10 bills will be T. So, do you agree that out of the 33, like there's 33 bills total, it would be however many $5 bills plus however many $10 bills is equal to 33? Do you guys agree with that? That's what the system would be. I don't know how many fives she has, and I don't know how many 10s she has, but those two summed together would be 33. Does anybody know what the money would be? It has to do with this. How much is each $5 bill worth? Plus how much is each $10 bill worth? And that equals 260. Anybody want to venture a guess what that would be? For the money, each $5 bill, you guys, is worth 5, right? So it's going to be this, 5F. Because if she has three $5 bills, how much money does she have? If she has three $5 bills, it'd be 15, right? If she's got four $5 bills, if there's four here, 5 times 4 is 20. So what the money would be, it's going to be $5 for every $5 bill she has, plus $10 for every $10 bill she has, and that's going to add to 260. So the two different types of bills were 33 bills total, but the money value of each bill, it's going to be 260 total. How is this set up? Substitution or elimination? Yeah, let's do elimination to review elimination. What do you want me to multiply the second system by? 5. Let's eliminate our $5 bills. Okay, so the first one we don't change. 5F plus 10T is equal to 260. The second system, you've got to multiply the 5 in. So 5F plus 10T. Are you getting 165? Okay. Erin, do you want me to add these two systems or subtract if I'm getting rid of the F's? Subtract. Yep. So we're going to subtract 5 minus 5. That cancels the F's. I made a mistake. Where's my mistake? Do you guys see my mistake? Right here. It should be 5F because I had to distribute this guy in. So 5F plus 5T is 165. 10T minus 5T is 5T. It's equal to 260, yeah, minus 165 is 95. Divide by 5, divide by 5. T is equal to 19. 19 what? What was T? $10 bills. She has 19 $10 bills. Okay. How many $5 bills does she have? Remember, they had to add to 33. So I would have used, remember in our second system we had this, F plus T was equal to 33. The number of 5s and the number of 10s totaled 33. If we know that there's 19 $10 bills, it'd be F plus 19 is equal to 33. Subtract 19 from both sides. and we would have 14 $5 bills. You're going to have two long answer exam questions that are similar to this. Make sure you do your context sentence. So the question is, he has 33 bills in total. How many of each denomination does he have? The sentence would be, Gary has 19 $10 bills and 14 $5 bills. That would be your sentence. And then you would double check. Does 19 plus 14 total 33? And it does, right? 19 plus 14 is 33. Then you would check $5 times each, how many $5 bills he has. So he has 14 $5 bills, right? So 5 times 14 plus 10 times how many $10 bills does he have? 19. So you would type this in your calculator, 5 times 14 plus 10 times 19, and it has to equal 260 in order for us to be correct. So 5 times 14 plus 10 times 19, thank you, and it's correct. It verifies in both systems. Okay, those are the three main types. So now let's set up the homework questions. I'll tell you what I want you to circle for homework, and we'll actually set up each one, and then you'll go through and solve them, and then by the time we get to the worksheet, you'll have an easier time. Okay, so the ones I want you to circle for now are 1 to 3. Circle 1 to 3, 6, and 7. And we are going to set all 5 of these up. So 1 to 3, 6, and 7. Okay, number 1 is the rectangle one. So get your rectangle drawn. You need 2 systems. See if you could figure out, like, what it should be is once you've done one of these, you should be able to set up the other ones. First system. A rectangle is to be drawn with a perimeter of 64. Maria, what was your first system? Yes, 2L plus 2W equals 64. The second system would be here. The length is, so here's your equals, and length is L. So it's going to be L is equal to 14 more than the width. So 14 more is plus 14. If it was 14 less, it would be minus 14, right? So 14 more is plus 14, then the width. What would the right-hand side be? L is equal to, yep, I always put the letter first, so I'm going to put W plus 14. And the reason why I do that, again, is because if it was 14 less, it would be W minus 14. So I always tend to write it in this order. Okay, how is this set up? We're not going to solve it right now. You're just going to tell me, how would you guys solve this? What is it set up for? It is set up for substitution. You do not have to do substitution, right? If you want, you could have subtracted L from both sides, or sorry, subtracted W and then done elimination, but it's set up for substitution. Okay. See if you could do the second one. It's the numbers. Pick X and Y for your numbers. And let's write let X be the larger number. And see if you could figure out, the first one should be very simple. The sum of two numbers is 3. Xavier, what would that be? The sum of the two numbers is 3. Any idea? The difference between two numbers was x minus y. What would sum be? X plus y. The sum of two numbers is 3. There's my equal. It is going to be x plus y is equal to 3. Second system. Twice the larger number is, okay, so there's my equals, twice the larger number. The larger number we said was x. Twice that would be what? 2x, right? The larger number is x, twice the larger number is 2x. So 2x is equal to, how would you do this? 36 more, that's plus 36. 36 more than what? 3 times the smaller. The smaller is y. 3 times the smaller would be 3y, right? So if you write things like this, then you'd be able to, the system would be as follows. 2x twice the larger is equals 36 more than 3 times the smaller. 3 times the smaller would be 3y, and we're going to add 36. Now, it's not really set up right now for either. You could do substitution in one step over here by subtracting y from both sides, or you could do elimination in one step by subtracting 3y. You decide, okay? Either, like I said, if you like substitution, you're going to have this. If you like substitution, x is equal to 3 minus y, and you put that in here. So if you like substitution, that's what you'd be doing. If you like elimination, your first system was x plus y is equal to 3. Your second system, you got to have your x's, then your y's, your equals, and your constant. So I'd have to bring my 3y over. So it would be 2x minus 3y is equal to 36. And what would you multiply the first system by if you're doing elimination? By 2, if you want to eliminate the x's, right? So you choose when you're doing your work. Do you want to do substitution or do you want to do elimination? Okay, number 3, I'll set this one up for you. It says 5 pencils. I'm going to call a pencil X. Okay, so there's 5 of them. 5 times however much a pencil is, and is going to be plus 4 pens. I'm going to call my pens Y, and there's 4 of them. That cost is, they're missing the is, but the cost is $6.15. That is your first system. 5 pencils and 4 pens cost, or it is, $6.15. The second system, 3 similar pencils. So we said that pencils were X. So 3 similar pencils. There's that and again, which is plus. 8 similar pens. Pen is Y, 8 of them. This cost is $9.85. So the second system would be 3x plus 8y is equal to $9.85. I would not do substitution. I'd be doing elimination. What would I have to multiply this first system by to do elimination? Oh yeah, actually I didn't, at first I was thinking eliminating the x's, and I was going to say multiply this by 3, this by 5, but Ainsley's right. I could just multiply this one system If I want to eliminate the y's, what would I multiply that first system by? By 2. Because then I would have 8 y's, and the y's would eliminate. Or if you wanted to eliminate the x's, you'd get the same answer. You just have to multiply this system by 5 and this system by 3. Okay, so you'll do that for the work. Let's go to 6 now, which actually, let's set up 7 first, because 7's a money one. So 7's like the $5 and $10 bills. So let's set up 7, and then we'll go to 6 last. Instead of having 5s and 10s, she only has quarters and dimes. Okay, so that's all she has, is quarters and dimes. You need to know that a quarter is 0.25 and a dime is 0.10. She has 103 coins total. So the first system is in her piggy bank. All she has is quarters and dimes, but she's got 103 of them. What would that equation be? That was like the 5s and the 10s. But think about your variables. Use Q for, Caleb, do you know what it would be? That's right. Q plus D is equal to 103. However many quarters she has, plus however many dimes she has, it totals 103 coins total. Second system has to do, when she adds up the quarters and dimes, they're $21.40. What would this be? So think about the money for the bills. It was 5 times every $5 bill. So it was 5F plus 10. What would it be? Yes. 0.25Q plus 0.10D. 25 cents for every quarter she has, plus 10 cents for every dime she has, totals, or it is $21.40. Now, the other class, half of them were doing elimination, and they multiplied this first system by 0.25. Okay, so you decide, do you want to multiply this first system by 0.25 and then you're going to eliminate your quarters? Or the alternate way, if you want to do substitution, is minus D, right? And then you get what Q is equal to, and you're going to take out Q here and put your substitution. You choose. Let's look at 6. I want you guys to star number 6. Okay, here's what it says. In a hockey arena, like if you buy tickets to an Oilers game, it says a seat at rink level costs 3 times as much as a seat in upper level. Is that generally true? Like, are tickets at rink more? Okay, so they're saying it's 3 times more. If you want to buy a ticket at the rink, it's 3 times more. So here's what we're going to do. We're going to call our rink level seats R, and let's call our upper level seats U. To do a question like this, like figuring out which one is 3 times more, I often have to just like look at numbers. Like I'm going to pick numbers. So here's what I mean. It says rank level is 3 times as much as upper level. Okay, so upper level is less. So I'm going to pick a price for upper level. I'm just going to pick $10. If upper level is 10, what would rink level be if it's 3 more? It would be 30. So my question is, what's the formula? U is equal to 3R, or R is equal to 3U? Because it says like 3 times as much, so that's going to be 3 times one of the variables. based on this example, like I just picked random numbers, right? I know that upper is less expensive, so I picked a 10 here, and then I tripled it. I could have put a 5 here and tripled it, right? What one makes sense? Raise your hand if you know, because like Ainsley knows, Jackson knows, Angel knows. Who else knows? Okay, so a few of you. Jackson, which one is it? Yes, it's this guy. R is equal to 3U. That is one of my systems. The rank level, it's 3 times upper level. Whatever the upper level cost is, you multiply by that by 3 and you've got what it is to sit at the rank. Okay, here is my second system. 5 seats at rank level. 5 seats at rank level would be 5R. Okay, so 5 seats at rank level cost, and remember that's usually is. So 5 seats at rank level is 112 more. So that's going to be plus 112. Then 8 seats at upper level. 8 seats at upper level would be 8U. Raise your hand if you know this system. 5 seats at rank level cost or is 112 more than 8 seats at upper level. Tristan, what would it be? Yes. 5R is equal to 8U plus 112. I personally would do substitution because they have what R is equal to. I'd be taking out that R and I'd be putting in 3U. So 5 times 3U is equal to 8U plus 112. 15U is equal to 8U plus 112. Join your U's, figure out what each upper level seat costs. Yes, you're good. Okay. So what would you, how would you join your U's? Are you going to subtract 8 or subtract 15? Yep, subtract 8. And then when you divide by 7, each upper level seat, which is the cheap ones, are $16. So then the rink side seats are 3 times that. So 16 times 3. Take 15 minutes or so, finish off those questions, and then I will hand out a handout and we will do the second part of this. So on the worksheet, look at this first question about the farmyard. It says, in a farmyard, there are pigs and chickens only. So let's use the letters P and C for the pigs and chickens.